Hello everyone, myself Dr. Feroza Demirachkar, and today we will see a 8051 program to transfer 10 bytes of data from the external RAM to external RAM. This is a general program logic where we will start with the initialization process. Okay, that is we will initialize and we will initialize the transfer process. Then we will load the source address. After that, load the destination address, then we will transfer the data, then we will increment the source address which we have loaded. Once the source address is being incremented, then the destination address will be incremented, then the counter will be decremented, okay, which we have set in this program to 10. Once the counter is been decremented, then we will check for the counter. If the counter has become 0, if it has reached the 0 value, then there is no need to repeat the loop. If it has not reached the 0, then you have to repeat the loop. This is the overall logic of the program. This is a general logic of the program. That is, we are initializing the transfer. We will load the source address, we'll load the destination address, then we will transfer the data, then we will increment the source address, increment the destination address, then we will decrement the counter and we'll check for the counter whether it has reached 0 or no. If it has not reached 0, then that is it is equal to 0 or no. If it is not equal to 0, then we have to repeat the loop. If it is equal to 0, then we have to stop. Next is the data transfer, that is transferring of the data. So here what we are doing, we are identifying the memory locations, that is we will determine the source and the destination address. Then we will load the data from the source, that is we will transfer the data from the source to the register. Once this is done, next step is we'll transfer the data to the destination, that is we are moving the data from the register to the destination. Then we will verify the data transfer, that is we'll check if the data is correctly transferred or no. Here the program it is designed to transfer the data from an external memory location at 3000 H to another external memory location at 4000 H. We will transfer 10 bytes of data, that is starting address from 3000 H to 3009 H. We will take the inputs and those have to be transferred to another external memory locations starting from 4000 H to 4009 H. Okay, and this program, it operates in a loop transferring a specified number of bytes from the source to destination. Here I have considered the number of bytes to be transferred as 10. You can change accordingly, that can be varied. The first step is initialization. Here the first step in initialization is setting the origin address, that is org0000H. This directive sets the origin address for the program to 0000H, which is the starting point of the code in the memory. Once this is done, the second step is load counter value, that is we will be loading the register R2 register R2 with the value 0AH for the loop. What is 0AH? It is 10. That is we are transferring 10 bytes of data. Therefore, here we have taken the load, here we have taken the counter value as 0A. So for that the instruction which is used is move R2 comma hash 0AH. So what does this does? This instruction initializes the register R2 with value 0AH, that is 10 in decimal, which indicates the number of bytes to transfer. Okay. After that, the next step is initializing register R0. Here the register R0, it is set to the starting address 30H, which will be used as the higher byte of the source address 3000H. Okay. For that we are using the instruction move R0 comma hash 30H. Once this is done, the next step is initializing the register R1. Okay, that is the register R1 is set to starting address 440H, okay, which will be used as the higher byte of the destination address 4000H. For that, we'll use the instruction move R1 comma hash 40H. After that, we will initialize the data pointer. Here the lower byte of the data pointer, it is initialized to 00H. Okay, so for that we'll use the instruction move dpl comma hash 00H. Once the initialization process is completed, the next step is execution of the loop. So these are the instructions which are used in the loop execution. Here we are using the label up. Okay, so this label up, it will mark the beginning of the loop. Here the first step or the first instruction is move dph comma r0. Okay, what we are doing here, this instruction move dph comma r0, this is nothing but the higher byte of the data pointer. Okay, here it will load the higher byte of the data pointer with the value r0. Okay, and sets the data pointer to the source address 3000H. So what we are doing here, we are initializing the data pointer first. Okay, first step is initializing the data pointer. For that, we are moving the value in R0 to the higher byte of the data pointer. Okay, once this is done, what we'll do, we will load the data from 3000H. Where the data pointer is initialized, it is initialized to 3000H. So now we have to read the data from this location, that is 3000H. For that we are using the instruction MOVX A comma at dptr. So here this reads the byte from the external memory location pointed to by the data pointer, that is 3000H, into the accumulator A. Okay, for that we are using the instruction MOVX A comma at dptr. Okay, then the next step is move dph comma r1. Okay, for that here this is similar to move dph comma r0. This was for the source source address. Now this is for the destination address we are doing, that is move dph comma r1. So here R1 is what? R1 is 40. So here the higher byte of the DPH, it will be 40. Now this move DPH comma R1, it will update the higher byte of the data pointer to the value in R1, setting the data pointer to the destination address 4000H. Okay. Then move X at dptr comma A. This instruction, it will write the byte stored into the accumulator A to the external memory location pointed to by the data pointer 4000H. Okay, here. So here the data is being transferred from 3000H. The data is being transferred to 4000H. Okay. After that, increment DPL. Okay, the lower byte, it has to be incremented. The lower byte, it was initialized to 00. Now it has to be incremented. So the lower byte, it will become what? It will become 01. Okay, then next instruction is DJNZ R2 comma up. So what it will do, it will decrement the value. Okay, this will decrement the value in R2 by 1 and checks if it is 0. That is, the loop will be controlled by R2. Okay, if it is not 0, the program jumps back again to the label. Okay, then it will repeat this process until and unless this R2 becomes 0 and the data transfer is completed. Okay, so here this was about the execution of the loop. Then next is we will enter a infinite loop at the end. Okay, by using this instruction H, S jump H, and a directive end. So here this H colon S jump H, it will jump to level H. So here the program counter jumps to the level H, creating a self loop here. It will create a loop here. Okay. And here effectively halting the program after the loop, and the loop has completed its execution. Okay. So the next step is the next, that is directive is end. Here it will indicate the end of the assembly program. Okay, this was about the initialization, loop execution, and halting of the program. Now here we will give the input from the source location 3000H. Okay, this is 3000H. Okay, and here we are giving at 3000H1, 3002 will give 2, 3000, sorry, this is 3000. At 3000 location will give 1, 3001 will give 2, 3000 2 will give 3, and so on up to 3009. Okay, so this will be the first byte, second byte, third byte, fourth byte, and so on. This data, it has to be transferred to the destination location starting from 4000H to 4009H. Okay, by executing the steps of the program. So this is the output. What we have done, we have entered these value at the starting location, starting address location 3000H to 3009H, and this data, it has been transferred to 4000H to 4009H. Okay, by a series of instruction. That is, there was loop control, we have used data pointers, and we have used certain registers. Now this is the overall transfer of data. That is, we have initialized the source location to 3000H, where we'll be entering the data, so that it will be transferred to what, 4000H. Similarly, the data which was there at 3001, it is transferred to 4001. 3002, it has been transferred to 4002, and the data which is at 3003, it is transferred to 4003, and so on up to it is up to 3009 to 4009. So now we will see the program here. This is the program. Okay, once again I'll explain the program here. First we will set the origin org0000H. Then we have the instruction move r2 comma hash 0AH. This will initialize r2 with 0AH, that is the decimal 10, and this will act as a loop counter. Then you have move r0 comma hash 30H. This will initialize the r0 with 30H, that is source address will start in the external memory. Then we have move r1 comma hash 40H. Here this will initialize r1 with 40H. Then we have move dpl comma hash 00H. So here it will initialize the lower byte of the data pointer to 00H. Then we have a loop whose level is up. Okay, so here the first instruction in the loop is move dph comma r0. This will move the contents of r0, okay, into the dph, that is the upper byte of the dptr. Then we have move x a comma at dptr. This will read a byte from the external memory at address pointed by dptr into the accumulator. The next instruction is move dph comma r1. This will move the contents of r1 into dph. Okay, and it will change the destination address here. Then we have move x at dptr comma a. So here it will write the byte in the accumulator to the external memory at the new address pointed by dptr. Then we have increment dpl. So this will increment, that is it will point to the next address in the block. After that we have DJNZ R2 comma up. So here it is decrement R2 and repeat the loop if R2 is not 0. Then we will halt the program. Okay, so this yes H S jump H is, it is an infinite loop in order to halt the program, and we'll end it. The next what we'll see here is what will give the input and what will be the output. So input is x colon. Why x? Because here we are taking the external memory, so we have to write it as x. What is the starting address? Source address, it is 3000h. So we are giving these data at 3000h, 3001h, 3002h up to 3009h. Then we will get this as the output at the memory starting from 4000h. Okay, so this is the flowchart. Here we will start with the instruction ORT 00H. So here it will set the origin. Then we have to initialize R2 with 0A, that is a loop counter. Once that is done, we'll initialize R0 with 30H, that is the source address. Then initialize R1 with 40H, that is the destination address, which will be later for 4000H. Then initialize DPL with 00. Once this is done, we will enter a loop here. Okay, and we'll check for R2. If R2 is greater than 0, then this loop will be executed. Otherwise, okay, just a minute. If R2 is greater than 0, okay, this loop will be executed. If yes, then you have to go through these steps. Okay, that is set DPH equal to R0. That is the source address. Now here the source address will become 3000H. Then read byte from external memory into A. So you have to read the data from 3000H to the accumulator. Then you have to set DPH is equal to R1. So here the destination address becomes 4000H. Then you have to write the byte from A, which you have got from 3000 into the accumulator. That has to be copied again from A to the destination address, that is 4000H. Then you have to increment DPTL. Sorry, you have to increment DPL. So it will increase the destination address and the source address. Earlier the destination and the source address was 3000. Now it will become 3001H, and the destination address was 4000. It will become now 4000H. Once that is done, you have to decrement R2. Okay, and you have to check whether it is greater than 0 or what. If it is not greater than 0, then you have to end the program. Now we will see the execution of the program. I will copy the program from this. We will open the Keel software. Maximize this. Go to project, new MOVX project. I'll use the previously used project. Yes. Okay. Search for the device microchip. Click on this plus symbol and search for 8089C51. Okay. Then click on no. So the target one is created here. Go to file, new file, type your program here. I will directly paste the program, then I'll save it. You have to always save the program with .asm extension. So it is external to external, ext to ext. I'll give this name .asm. So save. Now go to target, click on the plus symbol, right click on the source group 1, add existing files to group source group 1. Now search for your program. It was external to external, that is ext to ext, this one. Add and close. Okay. Now go to project, build target, So here you can see there are 0 errors and 0 warnings. Go to debug, then start or stop debug session. Okay. We want two memory locations, that is two memory windows. We have only one memory window here. The first memory window is we'll give the input here, that should be x colon 3000h. We will take another memory window, memory 2, for the output, x colon 4000h. Okay, here I'll give the input 1 2 3 4 5 6 7 8 9, and here I'll give it as 8. Okay, now we'll see the output. We'll see the output at memory 2. Go to debug and run. So here you can see the data has been changed. Earlier here it was 0 0. Now it has the data which was present here, it has been transferred or copied. So you get here 0 1 0 2 0 3 up to 0 8. This is the external to external transfer of data. Okay, hope you understand the program. Thank you.